Why are some languages more prone to off-by-one loop errors? Imagine trying to count the steps in a staircase and accidentally missing one or counting one too many. That's similar to what happens with off-by-one errors in programming. These mistakes happen when loops run one time too many or too few, often because of how the language handles counting and indexing. Some languages are more likely to have these errors because of their design. Many languages like C, C++, Java, Python, and JavaScript use zero-based indexing. That means the first element in an array or string is at position 0, not 1. If you forget this and write your loop as if counting starts at 1, you might run the loop one step too far or stop too early. For example, if you want to go through an array of 10 items, you need to run your loop from 0 to 9. If you accidentally write it to go from 0 to 10, you will try to access an element that doesn't exist, causing an error. How you write your loop condition also matters. Using less than signs like less than or equal to can cause confusion. If you write a loop with a condition like less than or equal to, when you should use less than, your loop might run one extra time. This is especially true when working with arrays or strings where the boundary is critical. Languages that requiring you to manage memory manually, like C, can be more prone to off-by-one errors. When copying strings or working with arrays, you need to allocate enough space for the null character at the end of strings. Forgetting to include this null terminator or miscalculating the loop bounds can cause bugs that lead to crashes or memory corruption. Another common source of these errors is the fence post problem. Imagine counting fence posts along a fence. If you have 5 sections, you need 6 posts. Counting the sections versus counting the posts can cause off-by-one mistakes. This problem shows up in programming when counting items or segments, especially if the programmer doesn't clearly understand whether to include the last item or not. Languages that use zero-based indexing, requiring explicit boundary definitions, and demand manual memory management tend to be more vulnerable to off-by-one errors. To avoid these mistakes, it helps to carefully set your loop boundaries, test edge cases like the first and last items, and use language features like range-based loops or iterators when possible. Doing thorough code reviews and paying close attention to your loop conditions can save you time and frustration when fixing bugs.